Right, this video we're going to be looking at how to use Pythagoras' theorem in order to find the missing sides in right-angled triangles. One of the key things we need to know about the triangle is that the longest side is known as the hypotenuse. The longest side can be found opposite the right angle. So, Pythagoras' theorem states that a squared plus b squared equals c squared. Okay, where a and b are the two shorter sides and c is the hypotenuse. Looking at this picture, we can see how this works. A and b are the two shorter sides. We can see that this base length is 3 units and the vertical length here is 4 units. And if we square those two values, so 3 squared gives you 9, 4 squared gives you 16, we can see that if we added all those squares together, that would give us 25 squares. Looking at the length of C here, we can see that it's 5 units long, and 5 squared gives us 25. So, let's start. First thing we're going to look at is finding the longest side, the hypotenuse. And what we're given here is the lengths of A and B. All right, they're asking us to find C. So, using our calculator, all right, we're going to be using these buttons here, the x squared button. So, I'm going to start off by finding the length of side A. Now, actually, it doesn't matter which of these is side A, as long as it's one of the shorter sides. So I'm going to start off with side A being this bottom one here. So side A is 6 centimetres. So if I type that in and then press this square button just here, I'm going to get an answer of 36. And side B is 8. And if I square that, I'm going to get 64. Okay? Now, what I'm going to do is add those two lengths together. So 36 plus 64 gives me a total of 100. I'm now going to use my square root button here and do the square root of 100, and that will give me the answer of 10. So here, C equals 10. So what we've done is we've squared that side, added those two numbers together and square rooted. All right? Square, square, add, square root. Okay, so let's add some mathematical proof to what we've just done by substituting the values of these two sides into this equation, Pythagoras' theorem equation, all right, and then solve that equation to show that both of these sides are equal. So first of all, I'm going to square side A. 6 squared is 36. Squaring side B, 8 squared is 64. And by adding those together, I get a value of C squared, which is 100. Now remember, these values at the moment are all squared. So if I add 36 and 64 together, I get 100, and that equals what C squared is over this other side, which is 100. Again, remember these values are both squared, so I'm now going to square root both of those values, and I get 100. Square root of 100 is 10. Square root of 100 is 10. So that's now proving the fact that A squared plus B squared equals C squared. And I've also found the length of the side that I'm after. Right, we're now going to have a go at trying to find one of the shorter sides. So this technique can be applied when we know the hypotenuse. So look for the right angle. If you've got the length of the side that's opposite the right angle, you've got the hypotenuse, and therefore you're going to apply this technique. Okay, so I've got Pythagoras' theorem up here. I'm going to substitute the values that I have into this equation, solve the equation to find out my missing value here. Okay, so 6 is going to be my value of c, so I'm going to square that. And on this occasion, 2 I've chosen to be my value of b. Although it doesn't matter, 2 could be my value of a. Remember, a and b are either of the shortest sides. Okay? So, let's give this a go. So c squared, which is 6 squared, so that's going to equal 36. B, as I said, is going to be 2 squared. 2 squared is 4. So a squared plus 4 equals 36. Okay, I'm now going to solve this like an equation. So I'm going to take away this value from both sides. That leaves me with a squared equaling 32. All right, now remember, we want the value of a, not a squared. So in order to cancel out that squared, I need to square root. So I'm going to square root. I'm going to do the square root of a squared, and I'm going to do the square root of 32. And that will give me a equals, now on your calculator you may well get this answer to start off with, 4 square root 2. Okay, that's just it in third form. So if you press your SD button, all right, so if you press SD, you should then get an answer of 5.6. I'm rounding this to 2 decimal places, 6. So that's going to be my missing side length, 5.66. Now, what I need to do now is just to have a little look before I move on from this question. The hypotenuse is the longest side, so my answer that I've just got needs to be shorter than that. So this answer needs to be shorter than 6 metres, and it's 5.66. So that's fine. Let me just write the units on there as well. So that's okay. I'm happy with that. So let's just summarise what we've done here, all right, in the steps. So we've squared c, we've squared b, and then we've taken away the value of b squared from c. So squared, squared, taken away, and then we've square rooted. So just to summarise what we've done in those 2 examples, all right? In the first example, we were finding the hypotenuse, the longest side. So we squared both sides, squared a, squared b. We added those sides together, and then we square rooted the answer. In the second example, when we were trying to find one of the shorter sides, we started off in exactly the same way. We squared the c, we squared the shorter sides, but in the equation, when we substituted into that equation, what we needed to do was subtract the value, all right, the value of the shorter side from the hypotenuse, and then we square rooted the answer. So the techniques are very, very similar. They both start off with squaring the 2 sides that we've got. They both finish off with square rooting your answer. All right, the difference is, and this is what catches people out, is that when you want to find the longest side, you add the sides together before you square root them. When you've got the longer side and when you're trying to find one of the shorter sides, you subtract the values before you square root the answer. That's the bit that you've got to remember. Do I add or do I subtract? Add for the longest, subtract for the shorter.